In question 1, we're going to use the definition of the derivative to find f prime of x. So in part A, we have f of x is equal to 5x. According to this definition, f prime of x is equal to the limit as h goes to 0 of, okay, the first thing is f of x plus h. So I look at my function, and in place of x, I'll put x plus h. So we get 5 times x plus h in parentheses. Then we subtract off the function f of x, which is 5x, and we divide the whole thing by h. Our goal is to simplify this part of the expression and then take the limit as h goes to 0. Here we can't just plug 0 in place of h because we would be dividing by 0. I think my first step is going to be to distribute the 5 and see what cancels. So we have that this is the limit as h goes to 0 of, okay, we get 5x plus 5h minus 5x all over h. I'll note that 5x and this minus 5x cancel. So that gives us the limit as h goes to 0 of, and we have 5h over h. I can cancel these h's. I am left with the limit as h goes to 0 of just the number 5. There are no h's in the expression, so therefore the answer is just 5. So in terms of the derivative, f prime of x, it is just the number 5. So if I want to find f prime of x for this function, I'll take the limit as h goes to 0 of, okay, any place I see an x, I'm first going to put an x plus h. So that's 1/2 times x plus h. Okay, and now I'll add 4. I then have to subtract the entire function, so I want to use parentheses here. So I'm subtracting 1/2 x plus 4. And I'll divide the whole thing by h. So in terms of simplifying this, I'll distribute the 1/2 into the parentheses. Technically, there's a -1 in front of there, so I'll distribute that. I have that this is the limit as h goes to 0 of, okay, in my numerator, I get 1/2 x plus 1/2 h plus 4. And then I get -1/2 x minus 4, all divided by h. At this point, hopefully some stuff cancels, and it does. A 1/2 x goes away, as well as a positive and -4. This reduces to the limit as h goes to 0 of, and we only have 1/2 h and then h in the denominator. So here the h's cancel. I'm really left with just 1/2. This is the limit as h goes to 0 of the number 1/2. There are no h's in the expression, so therefore the answer is simply just 1/2. This proves that f prime of x is equal to 1/2. F prime of x for f of x equals 100 is the limit as h goes to 0 of, the first thing in the definition is f of x plus h. There are no x's within this function, so f of x plus h is actually just itself 100. Then you want to subtract off the function, which is f of x. That is 100 as well, and this whole thing is divided by h. So if there's no x's within the equation, f of x plus h is 100, and so is f of x. In terms of simplifying this, this is the limit as h goes to 0 of 0 over h. Because we're saying h goes to 0, technically h is a non-zero number. 0 divided by some non-zero number can be reduced to 0. This is the limit as h goes to 0 of just the number 0. 0 is a number, doesn't depend on h, and so there is the answer. This proves that f prime of x is equal to 0. f prime of x is equal to the limit as h goes to 0 of, okay, I'm first going to put x plus h into all the x's. So I get x plus h squared minus 8 times x plus h, and then plus 14. Next, I want to subtract the entire function, so I'm going to use parentheses here. I'm subtracting x squared minus 8x plus 14. And this whole thing is divided by h. Okay, this is the limit as h goes to 0 of, and it's going to be a lot of terms, have a lot of terms in the numerator. I think for this one, I'm just going to note that this probably will occur often. If you square x plus h, you square the x, you also square the h, and you get two middle terms. You get two xh's. So I'm just going to replace this with this. That is, you have x squared plus 2xh plus h squared. Then I'll distribute in this negative 8, and I'll multiply this negative into the parentheses as well. So we get minus 8x minus 8h plus 14. Then I distribute the negative, and I get negative x squared. I get plus 8x, and then a minus 14. And this is all divided by h. At this step, a whole bunch of stuff should cancel. The x squares cancel. Let's see what else we have. We have a negative 8x and a positive 8x. And a positive and a negative 14. And there are no like terms that are remaining. So this is the limit as h goes to 0 of, we have 2xh plus h squared minus 8h over h. I can now cancel this h from the denominator because there's at least one h in every term within the numerator. So said another way, this is the limit as h goes to 0 of, like if you think of factoring, if you factor an h out from the top, you get 2x plus h minus 8 all over h. Therefore, this h and that h cancel. We now have the limit as h goes to 0 of 2x plus h minus 8, this thing. To evaluate this limit, we can now substitute 0 in place of this h. When we do that, we get 2x plus 0 minus 8, or simply just 2x minus 8. The answer to this problem is that the derivative is 2x minus 8. F prime of x is equal to the limit as h goes to 0 of, okay, I'm going to put x plus h in place of all the x's. So I get 7 times x plus h squared plus 2 times x plus h minus 1. The definition then says to subtract off the entire function itself. So I'm subtracting 7x squared plus 2x minus 1, being careful to use parentheses to indicate that I'm subtracting the entire function. And then I divide by h. I'll note that if you square x plus h, you get x squared plus 2xh plus h squared. So when I go to multiply all of this stuff out in this very first step, since I know this reduces to this, and 7's being multiplied to all of those terms, I'm just going to distribute a 7 to each of these three terms. So, that being said, this is the limit as h goes to 0 of, okay, the first piece is going to be, we get 7x squared. We then get plus 14xh. And then we get plus 7h squared. We are also distributing this positive 2, as well as this negative 1. And when we do that, we get plus 2x plus 2h minus 1 and then we get negative 7x squared minus 2x plus 1. And this is all over h. Hopefully a lot of stuff will cancel for us. Let's see what we get. In my fraction, okay, I have a positive 7x squared and a negative 7x squared. I have a negative and a positive 1. I have a positive and a negative 2x. And those are all of the like terms. So we are left with 14xh plus 7h squared plus 2h all over h. This is great because there's at least one h in all three terms, meaning I can cancel the h from the denominator. So this is the limit as h goes to 0 of, my numerator is equivalent to h times 14x plus 7h plus 2 all over h. The h's cancel. I now have the limit as h goes to 0 of 14x plus 7h plus 2. I can put 0 in place of h to evaluate this limit. We get 14x plus 7 times 0 plus 2, but we don't need to write the 7 times 0, and this means the answer is 14x plus 2. So that would be the answer to this problem. The formula for the derivative is 14x plus 2. To find f prime of x, I'm going to take the limit as h goes to 0 of, okay, putting in x plus h in place of x will give me 4 minus 3 times x plus h squared. And then I'm going to subtract off the function, which is 4 minus 3x in parentheses, all over h. Noting again that this x plus h squared is showing up a lot. I know it's equal to x squared plus 2xh plus h squared. All right, so let's just be a little bit more careful and plug all of this in. This is the limit as h goes to 0 of, okay, we get 4. Now, I'm distributing a negative 3 to these three terms. So that's going to be my next step. I know this part has these three terms. It's being multiplied by a negative 3, meaning it multiplies to all three of those. We get negative 3x squared minus 6xh, and then minus 3h squared. We will then distribute this negative 1 to both terms into the parentheses. So that gives us a minus 4 and a plus 3x squared. And this is all over h. For things that cancel, a positive and negative 4, a negative 3x squared and a positive 3x squared. And that's it. We are left with the limit as h goes to 0 of negative 6xh minus 3h squared. We can now cancel the h from the denominator because there is at least one h in both terms in the numerator. So if I factor out an h, I'm left with negative 6x and a minus 3h. So between the numerator and the denominator, I cancel the h's. This is now the limit as h goes to 0 of, we have negative 6x minus 3h. To evaluate the limit, I can simply put 0 in place of the h's, and there's only one of them. And it cancels that minus 3, and I'm left with a negative 6x. This is the answer to the problem. The derivative is negative 6x. Before we find the derivative of this function, we've been noting that if you take x plus h and square it, you get x squared plus 2xh plus h squared. What happens if you cube x plus h? That's going to show up in this problem. So if you want to figure out x plus h cubed, well, that means you take x plus h and multiply it to x plus h squared by adding the exponents. Those are equivalent. But if you want a procedure for doing this, we'll take x plus h and multiply it to not this, but this, x squared plus 2xh plus h squared. So I'll multiply the x to those three terms. I'll then multiply the h to the three terms, and we'll combine all like terms. So when we do this, we get x cubed, we get plus 2x squared h, and then we get plus xh squared. That came from taking x and multiplying it first to x squared, then to the 2xh, and then to the h squared. If we multiply in the h to those three terms, I'm going to write it below here, and I'm going to try to line up all of the like terms, which will make it easier to add these things together. So first, h gets multiplied to x squared. That gives us a x squared h term. So this to here, I'll write as x squared h and put it right below here. You can even note that you're saying there's one of them. Okay, h multiplied to here is a 2xh squared. So that's plus 2xh squared. And lastly, h multiplied to h squared is h cubed. I wrote it this way because there are four terms. There's x cubed, there's 3x squared h's, there's also 3xh squareds, and an h cubed. It's nice to do this ahead of time, just so we can plug this information in when we take the derivative of this function. So let's do that next. F prime of x is the limit as h goes to 0 of, step 1, put x plus h in place of all of the x's. And then second, you subtract the entire function, which is this, and you divide by h. So here we have x plus h cubed. I'm going to replace it with this. And at the same time, I'm going to distribute this negative into the parentheses. So let's do that next. This is the limit as h goes to 0 of, okay, we get x cubed. We get 3x squared h. We also get 3xh squared. And then we get an h cubed and a plus 1. By distributing this negative to both terms into here, we get minus x cubed and minus 1. And this is all over h. Okay, so what cancels? Hopefully a lot of things, but we'll see. Well, an x cubed and an x cubed here, a plus and a minus 1. So actually, only those four terms canceled. What is left over is the limit as h goes to 0 of, okay, we have 3x squared h. We have plus 3xh squared. And we also have h cubed. And this is all over h. It is now possible to cancel the h from the denominator because there's at least one h in every term in the numerator. So that is, this is the limit as h goes to 0 of, if I factor out the h, I'm left with 3x squared plus 3xh plus h squared. And this is all over h. These h's cancel. And I'm left with evaluating this limit. The limit as h goes to 0 of 3x squared plus 3xh plus h squared. These last two terms, if you put 0 in place of the h's, cancel to 0. And that means the answer itself is just 3x squared, which I'll write down here. That's what you get if you evaluate the limit. So altogether, we just figured out that the derivative of this function is 3x squared. And that is the final answer. To find f prime of x using the limit definition for the derivative, we're going to take the limit as h goes to 0 of, all right, in place of this x, I'll put an x plus h. I don't need parentheses. I can just write it as x plus h plus 3. I'll then subtract off the function itself, which is just x plus 3. And this is all divided by h. So where we go from here? There's a bit of a trick to this problem. What we're going to do is multiply this fraction by what is essentially 1. We're just going to write 1 in a very clever way that'll start canceling these square roots from this question. What we're going to do is look at this numerator and change this minus sign into a plus sign. And I'm going to put that over here into a fraction. So all I'm doing is leaving the first square root alone. I'll put a plus and then put this. Now, if you want this thing over here to equal the number 1, you have to write the same thing down into the denominator. And so that's what I'll do. This. Now, why is this going to help us figure out the problem? You'll see why this works after we multiply the numerators together. And we can also multiply the denominators together, but I think this is going to be as easy as just taking h and running it right here to say we've multiplied these two denominators together. All right, let's start simplifying this thing. This is the limit as h goes to 0 of, okay, think about this numerator. For starters, we have this thing multiplied to this thing. These two pieces are exactly the same. That's the same thing as saying you are squaring x plus h plus 3 under the square root. It'll cancel it. This multiplied to this simplifies to x plus h plus 3. And that's because when you multiply this to this, you are squaring this term, and it cancels the square root. Okay, you then have to multiply this to this term. I'll write it out. It's going to look like a mess. But we get, okay, the product of those things is the square root of x plus h plus 3 times the square root of x plus 3. I now want to distribute this into the parentheses as well. This term multiplied to this one will be exactly the same as this thing, except it'll be negative instead of positive. I'll write it as minus. We get the square root of x plus h plus 3, and then another square root of x plus 3 at the end. The last term that you would get is multiplying this to this. It's a negative times a positive, so I know it's going to be a negative. And we have the square root of x plus 3 times the square root of x plus 3, and that means you square this term, and it cancels the square root. What is left over is x plus 3. And you have to be careful. That is going into parentheses because you're saying the product of these two things is negative, and it's making this entire expression negative. My denominator, like I said, I'm just going to leave as h times parentheses x plus h plus 3 plus the square root of x plus 3. Now, why did this help us? This helped us because this completely cancels with this. There are no square roots in the numerator left over. Here's what it becomes. It's the limit as h goes to 0 of, okay, in the top, I don't need the parentheses around this because there's a positive 1. So I'll just put that's x plus h plus 3. Over here, we can distribute the negative into the parentheses. So there's a negative here, so I'll multiply it in. And that gives me a negative x and a minus 3. And my denominator is h times the square root of x plus h plus 3 plus the square root of x plus 3. All right, things should start to cancel, and they do. I can cancel this x with this negative x, this positive and negative 3. And what I have left over is, this is the limit as h goes to 0 of, okay, in the numerator, there is only h. And in my denominator, I have h times the square root of x plus h plus 3 plus the square root of x plus 3. It was good that I didn't multiply this h into the parentheses because, oh, wait a second, I can now just, it's already factored out in the denominator. I can simply cancel those two h's. This cancels with this, which really changes the numerator to a 1. We're getting very close to the final answer. This is the limit as h goes to 0 of, okay, we get 1. I don't need the parentheses in the denominator anymore, but we get the square root of x plus h plus 3 plus the square root of x plus 3. You are now allowed to put 0 in place of this h because you are not going to make the denominator equal 0. So just to write that part over here, I'm now going to put 0 in place of h, and that means I've evaluated the limit. In the top, you have the number 1. In the bottom, you have the square root of, well, it's really x plus 3 because the h becomes 0. You don't need to write it. And then you get the second square root of x plus 3. And said another way, this is 1 over, you have 2 of these square roots of x plus 3. This is the answer to the question. The derivative of our original function is 1 over 2 times the square root of x plus 3. F prime of x is equal to the limit as h goes to 0 of, okay, if I first put x plus h into this function, I get 1 over, and then we have x plus h squared, and then you subtract off the function, which is 1 over x squared. And this whole thing is divided by h. So here we have fractions within fractions, and if we're looking to simplify this, I think a thing to try would be to maybe get a common denominator for these two fractions and subtract them. So I'll note that the least common denominator is going to be the product of the two denominators. That's x squared times x plus h squared. Those things. So if I want to make one fraction within the numerator, this is the limit as h goes to 0 of, all right, basically what we're saying is we're taking this first fraction and we're multiplying it by x squared. So we're putting an x squared into the denominator, but also we're multiplying 1 into the numerator. And for this other fraction, what's missing is the x plus h squared, and so I have to multiply that to the top. So in the numerator, we have the following. You have one fraction whose common denominator is x squared times x plus h squared. The numerator of this fraction is x squared. I'll put it right here. And then I'm subtracting off the numerator of this fraction, which is x plus h squared. And this whole thing is divided by h. It's at this point where you could actually make these two separate fractions one single fraction. If you have a main fraction that's being divided by one term h, you can simply take this h and move it into this denominator, making the denominator of this main fraction 1, and that means we do not have to write it. So I'm going to re-express this as the limit as h goes to 0 of, so I'm not writing down this fraction because h is now moved here, and we get x squared minus x plus h squared, all divided by x squared times x plus h squared times h. So again, I'm really just copying this fraction down here, and I move the h here, and that meant that this fraction was no longer needed. I think my next step is going to be to square this out and then distribute the negative to the terms that are left over. So maybe just to note that if you have x plus h and you square it, that's x squared plus 2xh plus h squared. So for my next step, I'm going to write this as this, but I'm going to distribute a negative to those three terms. So here's what we get. This is the limit as h goes to 0 of, okay, we have x squared. Multiplying that negative gives us negative x squared minus 2xh minus h squared. And this is all divided by x squared times x plus h squared times h. Okay, what cancels? This x squared and this negative x squared. Actually, that's it. That is all that cancels. So let's write down what we have left over. This is the limit as h goes to 0 of, okay, we get negative 2xh minus h squared divided by x squared times x plus h squared times h. I can factor out an h from both terms in the numerator and cancel it with this single h. That will allow us to evaluate the limit by putting 0 in place of the remaining h's. So that is, this is the limit as h goes to 0 of, okay, if you factor out an h, you have negative 2x minus h left over. Your denominator is x squared, and then multiply by x plus h squared times h. That's helpful because those cancel. So continuing, I'll write this up here. This is the limit as h goes to 0 of, we are left with in the numerator negative 2x minus h all over x squared times x plus h squared. I'm going to put 0 in place of h because if you put zeros here and here, you are no longer dividing by 0. In fact, your top will just be negative 2x. The bottom is going to be x squared times x squared, like this. Negative 2x, and then we have x squared times x squared. This x squared came from, I put a 0 here, so you have x plus 0, but you can just write that as x, which you're squaring. This thing. Okay, that's negative 2x over x to the 4th. Okay, we can reduce an x. I mean, this is a final answer, but this one can go into 4 of those with 3 remaining. So we have negative 2 over x cubed, like this. This is the answer to the question. The derivative of the original function is negative 2 divided by x cubed. To find f prime of x, I'm going to take the limit as h goes to 0 of, okay, first I put x plus h in place of this x. I'm not going to put any parentheses around it. It's just 1 over x plus h plus 5. And then we subtract off the function itself, which is just 1 over x plus 5, like this. And the whole thing is divided by h. My first step is going to be to write this as a single fraction by subtracting these two things. But we need a common denominator to do that. So I'm just going to write down that the least common denominator for this problem is the product of the two denominators. That's x plus h plus 5 multiplied to x plus 5. So in terms of what's missing over here, that's x plus 5. So I'll multiply that in. In terms of what's missing over here, that's the x plus h plus 5, and I'll multiply in that as well. So over here, I'm multiplying by x plus 5 in the top and the bottom. And then over here, I'm multiplying by x plus h plus 5. And, you know, it's not a bad idea to really indicate that there's parentheses around all of these things. Let's see what we get. This is the limit as h goes to 0 of, okay, I have my main denominator of h. For the two fractions in the numerator, I now have my least common denominator. I'm not going to multiply it out. I'm just going to leave it as x plus 5 times x plus h plus 5. But the numerator, it's going to be x plus 5 times 1, which without parentheses, I'll just put x plus 5. And I'm subtracting the product of these two numerators, which is just x plus h plus 5. And I'm distributing that negative to every single term, so these parentheses are actually important. So I'll just put parentheses x plus h plus 5. When you're dividing fractions like this h can actually just move into this denominator. So I'm going to take this h, I'm going to write it right here. We'll only have one fraction remaining, which means I don't have to write this whatsoever. This is the limit as h goes to 0 of, okay, we get x plus 5 from here. I'm going to distribute this negative to all three terms. I think I might as well do that in this step. So we get negative x minus h minus 5. And my one denominator is now x plus 5 times x plus h plus 5 all times h. So this guy moved here, and I took the product of those three things, and I'm not going to multiply them out. Okay, in terms of what cancels, we can cancel an x and a 5, and we're left with just negative h. So this is the limit as h goes to 0 of, okay, we get negative h, then we have x plus 5 times x plus h plus 5 times h. And it works out in this problem that this h cancels with this one, and that leaves a negative 1 left over in the numerator. This is the limit as h goes to 0 of negative 1, then we have x plus 5 times x plus h plus 5. It's at this point where we can now actually put 0 in place of h to evaluate the limit. So right here, I can put in 0. I'll be left with an x plus 5 and another x plus 5. So after evaluating this limit, we get negative 1 in the top, we get x plus 5, and then another x plus 5 in the denominator. In fact, I would write this as negative 1 over x plus 5 squared. So this is the answer to the problem. F prime of x is equal to negative 1 over x plus 5 all squared. Let's start by finding the equation of the tangent line at x is equal to 2. Now there are two equations of the line that you can use, either the slope-intercept form or slope-point. And I think for this problem, it'll make more sense to use this form to figure out the equation of the line. But it's all right if you use this one too. You'll get the same answer. Okay, if you want to use this form of the line to get the tangent line, you need two things. You need the slope, and you need a point that falls on the line itself. Well, to start with, if you want to know the slope, m, that is exactly what the derivative tells you. So what is the slope at 2? We would need to figure this out. Well, in part D of question 1, we already figured out that the derivative of this function was equal to 2x minus 8. Therefore, if you want to know the derivative at 2, you can plug it into this equation and simplify it, and you get negative 4. So this is going to be the slope of our tangent line. It came from putting 2 into the formula for our derivative. We need one other thing. I have the slope, I now need a point that falls on this line, and this is where I can use the x value of 2 in the original function. If the x value is 2, if you want to solve for a corresponding y value, you can put 2 into this equation here. So that is, you also need to know, well, what is f of 2? It's equal to 2 squared minus 8 times 2 plus 14. And if you simplify this, the value that we get is positive 2. So we have all of the information that we need to get our formula. I know that the slope is negative 4, and that we have a point 2, 2 that falls on this tangent line. Slope came from the derivative. This y value corresponds to the x value off of this function. The rest is just plugging stuff in. I'll put negative 4 here. I'll put this 2 here. And I'll put this 2 here. So here's my equation. It's y minus 2 is equal to negative 4 times x minus 2. And I'm actually going to leave the answer just like this. If you wanted to, you could solve it for y equals mx plus b, but this is the equation of the tangent line. Before moving on, I actually went to Desmos and I typed in this equation, which is the function x squared minus 8x plus 14, and I also entered in the equation for this tangent line. And I wanted to see if it actually looked like this line was tangent to the graph at the x value of 2. And I mean, this is really just a way for me to verify my work, that, well, the point 2, 2 is on both the function and the tangent line itself, and that it looks like a slope of negative 4 is moving in the direction of the equation. So it's good to do this for this problem, just to check your work by looking at a graph. We're going to repeat this process for the x value of 4. So again, I want to figure out what is the equation of the tangent line to this graph at x equals 4. And for starters, you need to know the slope of the tangent line. And that comes from putting 4 into the derivative. And again, we already have a formula for it. It's 2 times 4 minus 8. And if you simplify this, it's 8 minus 8, which is equal to 0. So that is the slope of our tangent line. We also need the y value that corresponds to this x value of 4, and we can get that by putting 4 into the original function. And the original function was you square the x value, then you subtract off 8 times the x value, and then you add 14. And this simplifies down to negative 2. So we have a slope. Slope is 4. Sorry, the slope is 0. And we have a point. When x is equal to 4, y is equal to negative 2. If we put all this information into the equation of the line, we get y minus the y value, which is negative 2. That should be equal to 0 times x minus 4, this thing. Or y plus 2 is equal to 0 times x minus 4. Now, you could leave the answer just like this, but I mean 0 times x minus 4 equals 0, so you could also write this as y plus 2 is equal to 0. You could solve for y by subtracting 2 from both sides of your equation. It really doesn't matter which you use as your answer. This is definitely more simplified, but technically this is also an equation for the line as well. Again, for this problem, I went to Desmos and just checked, is this equation that I got here, does it actually look like the tangent line to this graph at x is equal to 4? And the answer is yes. It looks like we get a horizontal line for the tangent line to the graph at this point. The last x value to check was x is equal to 5. Again, I need my slope, and that's going to come from the derivative at 5. So that's going to be 2 times 5 minus 8. That's 10 minus 8, so that is positive 2. If you want the corresponding y value, we can take 5 and put that into the original function, which is this thing. Okay, so this time it looks like that simplifies down to negative 1. So we have all the information we need to get the equation of the tangent line. The slope is 2, and it contains the point 5 comma negative 1. If we put that into the formula for the equation of the line, that's y minus negative 1 is equal to 2 times x minus 5. Maybe I'll simplify this a little bit and write y plus 1 is equal to 2 times x minus 5, and I'll leave my answer like this. So the last thing I did was just use Desmos to check my work. I graphed in the tangent line and the original equation itself, and it looks like at 5, negative 1, that this is in fact the equation of the tangent line at this one spot. All right, for this problem, we want to figure out where the derivative is equal to 0, where is it negative, and where is it positive. I think it's worth pointing out that we already know the derivative, the formula for it, for this function. We saw that it's equal to 2x minus 8. So if you want to figure out where the derivative is equal to 0, and we already have a formula for it, you can take this and set it equal to 0, and then solve for x. So that would look like this. We'll take 2x minus 8, set it equal to 0. This is a pretty simple linear equation to solve where you can add 8 to both sides. You would then let 2x equal 8 and divide both sides by 2. And you get your x value of 4. And if you look at the graph, here's x is equal to 4, and it corresponds to this point on the graph, and that's where we have a horizontal tangent line. So at this x value, at 4, if you draw a tangent line there, it's a horizontal line, and the slope of a horizontal line is 0. So it's very easy if you have an equation to figure out the x values where your derivative is 0, but it should match up with what you actually see on the equation itself. You probably could have answered this one without this equation. You could just examine the graph. Notice that, oh, at this spot, it looks like we have a horizontal tangent. Therefore, 4 must be the answer to this question. Okay, well, that's where is it equal to 0. But what about where is it less than 0 or a negative number? What about where is it greater than 0 or a positive number? So if we want to figure out where the derivative is less than 0, where does that occur? That's going to be this portion of the graph. And the reason for this is because your function is decreasing. Every tangent line that you draw to the equation has a negative slope, and that means your derivative is less than 0. So the answer is going to be it's this portion of the graph. And technically, you would say, well, what are the x values for which this is true? And those x values are from negative infinity up to and not including positive 4. This is the same place where the function itself, not the derivative, but the function, is decreasing. So there's an important connection between these two ideas. If your function is decreasing, if it's moving downward, that means your derivative is negative because your tangent lines have a negative slope. Well, what about where the derivative is positive? Where does that happen? And that's going to be over here. Any tangent line that you draw to the equation over here is an increasing line, and that means its slope, its derivative, is positive. So the answer to this part would be everything from 4, not including 4, to positive infinity. The connection being that this is where your function is increasing. So just to recap, hopefully seeing the derivative equal to 0 is a good spot to look at first. It's like easy to identify. But once you know where it is 0, it must be either negative or positive at every other point. And to determine which it is, if your function is decreasing, your derivative is negative. If your function is increasing, then your derivative is positive.